Here's a pendulum. This pendulum can be mathematically modeled by this equation, where t is time, x of t is the angle of motion, it's this angle here, at time t, and it's measured in radians. We can use Newton's second law of motion, F equals ma, to derive this equation. X prime is the velocity, that's the rate of change of the angle x, so it's angular velocity. X double prime is the angular acceleration. So for simplicity, we are assuming the mass of this object attached to the string is 1, and this force is due to some kind of friction, could be air, caused by air, or by the attachment here, and that coefficient is the damping coefficient. Actually, it's divided by the mass, so we're assuming mass is 1, and this whole thing causes the damping. If there was no friction, this will go on forever, and this force here is due to gravity. So gravity is pulling this mass straight down vertically. That mass is m times g. G is the constant, the acceleration due to gravity. And then if you resolve that vertical force downward into two components, one along the string, the other one perpendicular to the string, which is in the direction of motion, then the one along the string will be cancelled by another force acting opposite to it at that point, but the one that is tangential will cause will affect the motion, so that will appear here, and that tangential component, by using trigonometry, can be figured out. So the coefficient here is 1, so that is, if you derive it geometrically, you will see that that 1 means that the length of this string is equal to g, the gravitational constant. So there it is, that's how you derive it. So if you apply Newton's second law, you usually have all of these on the other side. So this is acceleration ma, m is 1, equals to the total force. Now in this situation, there is no external force. For example, there could be some force that's a function of t. We can put it over here. That will make this non-autonomous system. But this is a little bit simpler than that. And also, if the damping coefficient was 0, then this term would not be here. The system would be simpler. And now the initial conditions. So x of 0 indicates initially how much that angle is, and x prime of 0 tells us the initial velocity. Okay, watch the next video to see how to use Mathematica to come up with graphical solutions, one of which we call the face plane.